Good afternoon, folks. My name is Stu McKenzie. I'm the Science Manager with the Criminal Investigations and Network Analysis, or CINA Center, here at George Mason University. Thank you for joining us for this socially distanced talk in a series that reflects our mandate, which is to support federal investigators with innovative technologies and approaches to combating organized crime. As we're exclusively online this afternoon, let me remind you, please, to keep your muted at all times, if you'd be so kind. As usual, we'll have a question and answer session at the end of this session, but if you have a question, you can type it into the chat box in WebEx, and we'll respectfully ask Dr. Chandra to address your question then. Before we begin, you may want to mark your calendars with some upcoming talks. We'll be reconvening next Thursday lunchtime, actually, that's April 30th, for a talk on using computational mathematics in combating criminal activities. We'll also host a talk on May 14th on enhancing disclosures in victims of sex trafficking. For full details about these and to register, please see our website. If you're not already on our mailing list, feel free to shoot one of us an email. We'll be very happy to make sure that you're kept in the loop. This afternoon, however, I have the great pleasure of introducing Dr. Siddharth Chandra. Dr. Chandra earned his PhD in economics at Cornell University, and he's a professor of economics at Michigan State University, where he also serves as director of MSU's Asian Studies Center. I first ran into Siddharth about a year ago at a conference, and we got chatting about some of his recent groundbreaking work on markets behavior and policy relating to psychoactive substances. We're thrilled that he's willing to join us today to talk to us a little bit about using open source economic data to trace illicit drug trafficking networks, as well as other illicit networks that intersect or overlap with them. The title of his talk this afternoon is Using Economic Principles to Identify and Understand Drug Trafficking Networks. Siddharth, thank you so much for joining us this afternoon. We're thrilled to host you. And with your permission, I will hand over to you for your presentation. Thank you, sir.
Thank you so much, Stuart. And thank you also to Kerry Riddle and Tony Stefanidis. I believe he's at another university now, but still engaged with with CINA at George Mason University. It's a real honor and pleasure to be invited and the featured speaker today. Let me say a little bit about my background so you understand where I'm coming from. The study of trafficking, illicit trafficking of networks in general, is a very interdisciplinary effort. And so we come from different places intellectually, and we use different languages. I am an economist by training. Economics very heavily uses the language of mathematics, but I understand that this is an interdisciplinary audience, so I'm going to try to convert some of the concepts into language that I think may be a little more accessible across the disciplines. And so if you have any questions, please, as Stuart said, you're more than welcome to ask them, and I'll try my best to answer them. So the title of the presentation today is Using Economic Principles to Identify and Understand Drug Trafficking Networks. And I'm going to explain in a few minutes the philosophy of this. It's driven by economic principles. So let's see. Okay, it's advancing. So by way of background, as everybody probably knows, drug trafficking is a major problem. It involves on the consumer side and approximately 275 million people. 275 million people are estimated to have used an illicit drug at least once in 2016. This is from the United Nations, the UNODC's World Drug Report of 2018. Major drug categories with which most of you are probably familiar include opiates, which contain the well-known drugs heroin, opium, and morphine, but others as well. Cocaine and its derivatives. Cannabis, which is actually in various stages of legalization in the United States. And then another category that we call ATS, amphetamine-type substances. Now, I've just included 4 of the most traditional drug categories. There's been a proliferation over the past decade in other types of pharmaceutical. And I'm very happy to answer questions about those as well. Those will not be the focus of this presentation, however. So knowledge of drug flows is a very important input into drug control efforts. If you know how drugs are flowing, law enforcement, but also efforts to try to prevent consumption or production of the drugs at the beginning and the end of these supply chains can be more effective if we know how these drugs are flowing. This knowledge requires information about the location and movements of illegal drugs. And of course, a basic problem is because these drugs are illegal, people who engage in the trafficking of these drugs are really not going to voluntarily make the information available. So accurate information about drug flows is quite scarce. And one of the things I found very surprising about 10 to 15 years ago when I started thinking about these problems is there is a lot of information out there, some of it of an economic nature, that is not yet being optimally used. And even though some of that information is inaccurate, it's noisy, if you will, it can be quite useful in understanding drug markets and drug trafficking networks. So what I'm going to strive to do today is give you an example, a series of examples of how we can exploit the information inherent in economic data to figure out how drugs are being trafficked. Okay? So the basic premise of this presentation is that economic data on prices, quality, primarily purity, and quantities, so the amount of drugs that are being seized, these data actually contain signals about how drugs flow across space. And we can exploit that information to get a sharper picture of what's happening. So the objective of my project, which has now gone on for the better part of a decade, is to develop and test a broad framework for surveillance of trafficking of illegal drugs using economic data. This, by the way, has application to other illicit or illegally trafficked goods, including people. So not just goods, but people. The data that we've focused on include prices, seizures, purity, and other kinds of related information. And we're going to use basic concepts from economics, an area of analysis called network analysis that straddles multiple disciplines, including engineering, sociology, and computer science, and statistics. So the strategy is going to be to examine and use data on the prices of drugs, on seizures, on their purity, to try to infer flows of illegal drugs across regions, across space, across geographic space. Okay? And we've now written papers that look at domestic issues primarily, but these also have cross-country applications. So some of the selected examples that I'm going to show you in the presentation include how we can think about city-to-city flows of drugs like cocaine. We've written another paper on MDMA, ecstasy. The same source of data can be used to look at methamphetamine and other types of drugs as well. The other example I'm going to show you is a cross-jurisdictional set of studies on country-to-country flows of heroin in Europe. We'll also look at cocaine flows in Europe. One other thing I'd like to add, and this is a relatively recent project. It's actually in collaboration with a colleague, Talia Benitez at Michigan State University. We're also looking at data now on prices of cocaine at various stages of production in Colombia. And we're beginning to try to get a picture of how cocaine is trafficked within Colombia before it is exported for consumption worldwide. So let's think about prices as an example, and a lot of this logic applies to purity data and seizures data as well. So the big question is, what can prices of illegal drugs tell us about drug flows? And it turns out that if we put into place just two very simple principles, we can actually extract a lot of information about these prices. Okay? So the first piece of information, or the first principle, is that the price of illegal drugs, the prices tend to go up as they move from one jurisdiction to another. Okay, and the logic is the same as the logic you'd find in any kind of good that's being transported across space. Okay, so for example, we know that in order to transport a good from the producer to the consumer, you're gonna have transportation costs built in, and that's going to raise the price the farther away you go from the source. In addition, we know from some research by Jonathan Corkins at Carnegie Mellon University that as a drug moves from the producer to the end consumer, it usually undergoes a series of transactions, right? That series of transactions involves progressive marking up in the price, but also the accumulated risk. With every transaction comes a risk that the goods, the drugs in this case, may be lost, and that risk tends to get built into the price as well. Okay? So prices tend to go up as drugs go from the source to the destination. And that's going to allow us to think about the direction of flow of drugs. Okay. And the second principle is that prices in two markets that are connected will tend to move in lockstep. Okay. So for example, if I'm a sender and you're a receiver, if we are two different markets, and today I'm cheap and I send to you, you're going to be cheap with that little bit of a markup. But tomorrow, if my price shoots up, I'm going to probably try to pass that on to you. It's going to go up as well. I'm going to retain some kind of markup as well. Okay? So these are the two basic principles. And just to give you an appreciation for how compelling price data can be for understanding drug trafficking networks, this is a slide of the price of powdered cocaine in cities of the United States. I got these data from the National Drug Intelligence Center. It was closed down in 2012, but prior to that, they had an active program of collecting price information. And what we did is we sorted the prices in about 110 cities in the US by quartile. Okay, so the cheapest cities in the map here are the ones that have red circles around them. So you've got Sacramento and San Francisco in California. You've got a whole cluster along the US-Mexico border, right? They're the cheapest cities. And what you can see is this is really a geographer's dream to have data like this. As you move to the north and the east of the country, the prices start going up, okay? So the red prices, the red cities are the cities that are in the lowest quartile for prices. The orange cities are the ones in the next cheapest group. The green cities are the ones in the next cheapest group, and the blue ones are the ones that are the most expensive. Okay. These, by the way, are wholesale prices of cocaine. They're not retail. So they probably are insulated to some degree from the purchasing power that retail customers can use to bid up the prices. Okay. So we've tried to factor out the demand side, if you will, of this relationship to show this. Okay? So here we have a map that has a very clear price gradient from the southwest of the United States to the northeast. And of course, if you think about where cocaine is coming from, well, it's coming from South America originally. There are 3 or 4 countries in South America that are the largest producers of cocaine. It's often processed there into hydrochloride. So you have a paste, it becomes a base, it's processed into a hydrochloride, and then it's sent across to wealthier markets like the United States. Okay, so the cocaine is coming from South America. It hits America cheap. And as it moves across America, it becomes more expensive. All right. Now, how can we convert this basic intuition and those two basic principles I told you about into a notion of how the entire network looks, right? And basically what we do is we look at every possible pair of cities in that map, right? So if I go back to this map of prices, let's say we've got Kansas City, Missouri, right? And we are looking at, and we pick Grand Rapids, Michigan, right? This is a city pair. And what we're going to do is we're going to compare the price in Kansas City with the price in Grand Rapids. And you can see that Grand Rapids, because it's green, is more expensive than Kansas City. And what that price differential tells us is if Kansas City is sending to Grand Rapids, and we haven't established that yet, if Kansas City is sending to Grand Rapids, if Kansas City is linked to Grand Rapids, then the direction in which the drug is flowing must be from the cheaper city, Kansas City, to Grand Rapids, the more expensive city. Okay, so price gradients, price differentials tell us about the direction of flow. And then the only remaining thing for us to think about for the relationship between, let's say, Kansas City and Grand Rapids is, are the prices moving enough in lockstep to allow us to infer that there's probably a connection between the two cities, right? And so what we do is we look at the price over time for these two cities. We calculate a simple measure of co-movement. The most common one is the price correlation, but you can use other fancier measures if you like. And then we ask the question, is this correlation high enough that it kind of beats a lot of the other correlations that we would see? Because generally speaking, prices of a good tend to move together nationally. But is this high enough above that correlation to justify an inference that these two cities are connected, right? So that's the basic idea. And of course, this raises a related question. We know that cocaine prices across the United States in the cities tend to all be correlated. Why? Because they're coming from a more or less common source in South America. So if something happens in South America to the price, that's going to be passed on to all markets in the United States. So we have to ask ourselves the question, above what level of correlation? How high do we want that correlation to be in order to say, yes, this pair is in fact a linked pair? All right. So in order to do that, we need to start thinking about the measure of correlation above which we're going to make the inference of linkage, right? And we're going to have to figure out what is that threshold. So in order to do that, we need some additional information. And basically the method that we developed was we said, let's look at what's out there in terms of anecdotal information. So if you go to the drug intelligence agencies, to the various reports, for example, on the high intensity drug trafficking areas, that's a huge program in the United States today, you sometimes pick up an idea about, okay, it's going from, let's say, Dallas to Atlanta, Georgia, right? And the moment you see that kind of link, you write it down. And you create a collection of these kinds of linkages and you put them into an anecdotal list, okay? So now we have an anecdotal list of linkages that have been established by the drug intelligence and other agencies in the United States. And what we're going to do next is we're going to go back to our data and we're going to say, okay, let's try a whole bunch of correlation thresholds. And let's generate a list of inferred linkages. In other words, if the correlation for, let's say, Kansas City and Grand Rapids is 0.65, and we try a correlation threshold of 0.5, well, the correlation for Grand Rapids and Kansas City is higher than that, so we're going to say, yes, we infer that you are linked. But as we ratchet up that threshold, and we get to, let's say, a threshold of 0.70, we will no longer infer that Grand Rapids and Kansas City are connected, right? So the calibration method that we use to figure out the optimal level of correlation in order to infer linkages between cities is this process of ratcheting up that correlation threshold. For each threshold, we generate a list of pairs of linked cities, and we compare each of those lists with the anecdotal list of linkages. Okay, so we're going to try all possible values of the correlation threshold, 0, 0.01, 0.02, 0.03, etc. For each value, we are going to generate what we call an inferred list of linkages. And then we're going to compare each of those inferred lists with the anecdotal list. And there's going to be lots of them. There's going to be over 100 of these inferred lists, each one corresponding to a different correlation threshold. Okay, and we're going to find that one of the correlation thresholds generates an inferred list, right, that best matches our anecdotal list. It's not going to be the same because our information on price correlations is going to give us pairs that are not on the anecdotal list. And the anecdotal list is always going to have some pairs that are not on our inferred list. But there are ways to calculate. So we use something called a concordance rate, which basically says how similar is one list, your inferred list, to, so how close is your inferred list to the anecdotal list, okay? We're going to use a concordance rate to measure that closeness. And then we're going to figure out where that concordance rate, for which level of threshold correlation is that concordance rate the highest, okay? And that's going to be the threshold that we pick in order to generate our list of inferred linkages. Okay? So that's the basic idea. Now, let me tell you about different places you can get your anecdotal list from. Here's one possibility. These are maps that the National Drug Intelligence Center used to publish. This is a map, by the way, of cocaine, movements of cocaine into the United States. And if you remember that price map I showed you for cocaine, it matches quite well with what we see in this map of arrows, right? So you can already see how price data can give you a lot of compelling information about how markets work. All right. I left the slide blank for a reason in case I needed to do some illustrations. I don't yet. In the Q&A section, I may need to come back, so ignore that. So here is a graph. And what we have on the x-axis here is about 50 different values of the correlation threshold for which we generated lists of inferred linkages. And we compared each of those lists of inferred linkages for 0.5, for a correlation threshold of 0.50, 0.51, 0.52, with that anecdotal list that we'd created from the verbal reports of the intelligence agencies. And based on that, we computed what's up here to the left side of the graph, a concordance rate. Okay. And then we computed that for each of a whole bunch of possible correlation thresholds. And what we found is a correlation of 0.73. Okay, so that's a measure of how much in lockstep these prices need to move. A correlation of 0.73 was gave us the maximum concordance between the inferred list that was generated by that threshold and the anecdotal list. Okay, so what did we do? We concluded that we're going to choose a correlation threshold of 0.73. We're going to take each pair of cities in this map. We're going to calculate the correlation of prices between that pair. And if that correlation exceeds 0.73, we're going to infer that that pair of cities, in this case, the one I'm circling is Bismarck and Fargo, North Dakota, are linked in a trafficking relationship. Remember, one of these cities is going to have a price that's higher than that for the other. That's going to tell us, okay, we inferred that you're linked. Now we can even talk about the direction in which the drug is flowing. Okay. So the power of this is you've got 100 cities here. If you calculate the number of possible city pairs, for those of you who've done permutations and combinations, that's 100 choose 2. It's approximately 5,000. We've got 5,000 pairs of cities for which we can do this exercise. And for each of those pairs, we can infer whether that pair is linked or not, and then in what direction the drug is flowing. Okay? So this is the power of the price data. And once you've done that, you've got an inferred network. You've got the whole network with arrows going in different directions. Okay? So that's the basic principle here. I wanted to spend a little time on it because this really underlies a lot of the results and a lot of the empirical phenomena I'm going to talk to you about in the coming slides. Okay. So based on that, based on those calculations, we can start asking questions like, which cities tend to have lots of outward linkages? So arrows going away from them. In other words, their prices are very highly correlated with the number of other cities, and their prices are lower than the prices of the cities with which they have high correlations. Those are outward links. Okay. So as you can probably expect, a lot of cities in the southern belt of the United States will tend to have prices that are lower, but that are highly correlated with cities that are further north and east. Okay. So the red cities here are the ones that had the most outward linkages. And you can see from this legend, the hierarchy of cities here in terms of outward linkages. Okay. We can do a similar exercise for inward linkages. Here, the red cities are the ones that have high correlations with many other cities, but the prices are higher. The wholesale prices of cocaine are higher. Okay? So these are inward linkages. And then you can go on and say, okay, well, let's look at a combination of outward and inward linkages, and let's start clustering these cities into different groups, each of which contains cities that share characteristics, but the group itself is different from other groups of cities. Okay. So, for example, the red cities are what we call source cities. They tend to have lots of outward linkages, but very few inward linkages. Okay. The orange ones have a healthy number of outward and inward linkages. We call them transit cities. It seems like wholesale cocaine is moving in and it's moving out of those cities. And the yellow ones tend to have lots of inward linkages, but not many outward linkages. Okay. And then we have a bunch of gray cities that have neither lots of outward nor lots of inward linkages, and we label them isolates because they don't seem to be heavily integrated into the network of powdered cocaine flows. Okay, so this is an example of the kind of work that we can do using those two very simple economic principles on price data. So if we evaluate the results here, for cocaine, the flow pattern is what you would expect, right? I showed you that map of arrows that the NDIC had created. And guess what? The price-based analysis shows you something very similar. Cocaine flows from the south and west of the United States to the north and east, and this is consistent with the South American source. Okay. Very importantly, and this is extremely important, you might say, okay, you got an anecdotal list. What's the value added from doing this analysis? Well, the answer is, remember, from the price data, we have information for over 100 cities. The anecdotal list is a lot less comprehensive. It's kind of scattershot. You're lucky if you have information for about 25 or 30 cities and how they're connected to each other. Okay. So what our inferred list allows us to do is, after calibrating it with some information from the anecdotal list, we can now talk about a much bigger and more detailed picture. We've got 110 cities in the mix. Okay, not just those 25 that I mentioned on the anecdotal list. Okay. So, and at this point, I'm just going to show you a variety of applications of this research agenda. We have about 15 to 20 minutes left. And I'll go over some of the striking phenomena that we see. The first one I wanted to show you is an application to cocaine and heroin flows in Europe. And this is because, if you remember one of the earlier slides, I said I'll talk to you about city to city linkages. You've seen one example with the cocaine market in the United States. I'm now going to show you some country to country linkages. Okay. So if we take a look at the cocaine price in Europe, and these data are from the United Nations, the UNODC. I believe they're sourced from the EMCDDA, but these data are published. This is public information. It's out in the World Drug Report. Okay. So this map shows you the average cocaine price in Europe over about a decade in the early 2000s for 17 different European countries. And what we did is we said we're going to categorize the price into low, medium, and high. We're going to take roughly 6 countries and put them in the high, 6 in the medium, and 6 in the low, based on how high or low they're. Okay. Now, what you should see is a pattern that looks a little bit familiar to the United States pattern. Where is the cocaine cheap? Well, it's cheap in Spain and Portugal. And it's cheap around sort of the midsection of the main part of the continent of Europe, right? And if you think about where cocaine is coming from into Europe, well, where is South America in relation to Europe? It's down here, okay? So cocaine is coming across the Atlantic. A lot of it seems to be landing in Portugal and Spain. And then it seems to be going through the countries in the midsection of Europe before ending up in these regions that are, at least in relation to the location of South America, peripheral. Okay, they're sort of on the outer easternmost limits of Europe in relation to where the cocaine is coming. Okay, so these are cocaine prices. We did the same kind of analysis. We looked at price correlations and price differentials to talk about direction of flow. And we came up with a categorization of 17 European countries based on whether they were receiving cocaine or sending cocaine or both. Okay, so we did the whole calibration exercise, same concept that I showed you earlier. And what we found is these are the countries that tend to have the most multiple or at least one outward cocaine linkage. Okay, so remember here the relationship is between each country and up to 16 other European countries. Okay, the red countries here are ones that seem to be sending to more than one other European country, and the one orange country, Italy, is sending to one other European country. Okay, and I want you to now pay close attention to the next slide. So these are outward linkages. The next slide is going to show you inward linkages. Okay, and tell me what kind of movement you see. Well, we go from outward to inward. Okay, I'm going to go back. These are your senders. These are your receivers. Senders, receivers. And what you should be seeing is it's almost like the cocaine is moving from the western side of Europe to the eastern side of Europe. And this is what you'd expect given the source of the cocaine. Okay, so one more time, senders and receivers, right? Okay. And then based on that, we can talk about the flow status of cocaine in Europe. We can put countries into categories of destinations, isolates, sources, or transit countries, just like we did for the cities of the United States in relation to powdered cocaine. Okay. And so I'm going to go now to the story of heroin in Europe. It's going to look at the same time period. And I'd like you to remember what happened in the case of cocaine. These are senders. These are receivers. It seems like the cocaine is going from the west to the east. Okay. Now let's look at heroin. Okay. So for cocaine, the flow pattern is what you'd expect. It appears to flow from the west to the east. It's consistent with the South American source. And what you're going to see is very interesting, is it's kind of the opposite of the story with heroin. And the reason is that heroin, a lot of it, at least in the early 2000s, it's changing a little now as South America has gotten into the production mode for heroin as well. But it used to be in the early 2000s that the dominant suppliers were from the East. They were from the Eurasian side, the Golden Triangle and the Golden Crescent. These are terms that you may have heard. They refer to countries in Southeast Asia. That's the Golden Triangle. This is Thailand, Burma, Laos, those regions. And the Golden Crescent is the much more famous Afghanistan area, right? So, and Iran. Okay, so now this is the average heroin price in Europe. And where are the red countries this time? They're actually on the eastern side of the continent. They include, again, countries in the midsection of Western Europe, as well as Greece, okay? Again, the midsection of the country is, a part of it is orange. And then look at where the countries are the most expensive. There's a notable exception here in Austria, but the other 5 of them are all in the periphery on this side of Europe, right? And what I'm going to show you next is the same analysis. We're going to talk about senders first. These are senders. These are countries with at least one or multiple, if you're red in color, outward linkages. And these are receivers. Okay, so senders of heroin, receivers of heroin. Tell me if you see some movement. Senders, receiver. The movement I see is coming from this side. Okay, and that is consistent with our Golden Crescent and further east our Golden Triangle sources of opium and then ultimately heroin into Europe. Okay. Again, we can categorize countries by flow status. I'll skip that. You've already seen a couple of examples. Okay, so that's the basic story. And I had mentioned that there are additional types of data that we can use to try to figure out what's going on with drug flows. Turns out seizures and purity can tell us quite a bit. Okay, and they can actually help us triangulate. So let's say prices tell us this is the way the flows look. Seizures, to the extent that they contain information, seizures of drugs or purity, can help us confirm or call into question some of those phenomena that we see with price data. Okay, they can help us refine our information. So what I'm going to do next is I'm going to show you one example. It's just going to be a very quick example. We're going to use price differences to infer the direction of the flow of the drug, like we did earlier. But now we're going to use not only price correlations, we're also going to use the correlations of seizures across cities or countries to infer linkages. And here's the logic for that. If you think about how drugs are flowing, think about them as flowing through a pipeline, right? And sometimes that pipeline is flooded, and sometimes there's just a trickle going through the pipeline. Well, if 2 different cities are located on that same pipeline, right, and there's enforcement activity going on, then you would expect when the pipeline is flooded, the seizures go up in both of those cities, right? And that's just because the amount of drugs that are flowing that underlie the seizures are typically 10% or less than the total volume that tends to flow through these pipelines. Okay, they're a very small fraction. So they are a reasonably good indication of what's flowing underneath. They're noisy, but they're a reasonably good indication. So what we can do is we can use seizure correlations. If one city along a flooded pipeline experiences a bump in seizures, chances are other cities down the pipeline are also going to see bumps in quantities seized. So that's the logic that we use here. And the only difference with what we did earlier is now the threshold correlation is not just going to be, here is the price correlation, 0.73 above which you can infer 2 cities are connected. Now we're going to require that your correlation for seizures is also above a seizure-specific correlation threshold. And you've got to fulfill both the criteria now for us to infer that you are linked. So it's a much tighter requirement. Okay, it's a stronger requirement. You can weaken it by saying, well, if you qualify on either one of these correlation thresholds, we'll let you in. That's another possibility. If you really want to be strong and you want to be a little more certain about what's going on, you want to qualify on both of those dimensions. Okay. And just as I showed you a graph for this was a graph, if you remember, for the price correlation threshold. Now we are dealing with price correlation thresholds on one axis, but now you got a seizure correlation threshold going into the graph, if you will. It becomes a three-dimensional picture, not just this one little curve. And this is what it looks like. Okay. So now we got a price correlation threshold and a seizure correlation threshold. For each possible pair of those correlations, we create an inferred list and we compare it with the anecdotal list. So now we do it 100 times 100 times. That's 10,000 different pairs of price and seizure correlations. And for each one, we crank out a list, an inferred list, and we compare each of those 10,000 lists with our anecdotal list. And we pick the pair of correlations. In this case, it's actually a bunch of them. It's a bunch of intervals for which the inferred lists are maximally or most concordant with the anecdotal list. And then we use those thresholds to generate our list of what our price and seizures data are telling us about the market. Okay, so this is just a little bit more complicated than what happened earlier. The basic message is you can use seizure thresholds as well. One more idea, I'm not going to have time to go over it in detail. Let's think about the purity of the drug. Okay, so we know that as a drug is trafficked, the price tends to go up with every transaction. But what do you think happens to the purity? Well, chances are it's not going to go up. If you get pure cocaine hydrochloride coming into the US and then it's transacted and transacted and transacted, the purity is not going up. It's either staying the same or going down, right? So you can now build in the notion of purity differentials to start thinking about directions of flow, and purity correlations to start thinking about linkages as well. Okay, so purity data have the power potentially to give us a lot of information about trafficking patterns as well. All right, here's a second extension of this research project. Remember, using this method for each pair of cities or countries, we can figure out whether we think they are linked, and if they are linked, in what direction the flow is happening, right? And using that, we can crank out an entire network of inferred flows. Well, once you have a network, it opens the door to all kinds of analysis using principles of network analysis, right? And so one of the things that we've done is we've gone into a variety of disciplines, engineering, sociology, other disciplines in the social sciences and natural sciences, and pulled out concepts of network structure and network flows that we think are the most relevant for the analysis of drug flow networks. Okay, and we started using those to think about how drugs flow across space and what some of the implications might be for law enforcement and the research community to better understand and enforce laws. So some of the things you can do, you can identify nodes in the network that are important in some sense. Importance itself has many different definitions in network analysis. We have the concept of hubs, we have authorities, we have central nodes that are central in some kind of betweenness sense. Are they critical for connecting different nodes together? We have the notion of cores. What are the nodes that together form the core that have the highest density of links with each other? And what are the nodes that don't lie in the core? What are the ones that lie in the periphery? And what can this tell us about trafficking organizations and structures? So we can examine the properties of the network of flows and we can compare the networks. We're up at 12:40, so I'm actually going to zip through these two slides. I can come back to these. But here is a comparison of the cocaine and heroin flow networks that I showed you earlier for Europe. And we made some very interesting findings. I'll give you just one example because I want to move on to two other extensions of this project. One very interesting example we found was we did something called a triad census. So a triad census, what it does is it takes every single set of 3 different nodes in a network and asks the question, what does that set of 3 nodes look like in terms of arrows, right? So if you think about 3 nodes in a network of this kind, one example of a structure is there are no arrows connecting any of these nodes, right? That's what we call the empty subgraph. Okay. You can have a set of 3 nodes, and I'm underlining these on the table, in which there's just one arrow connecting a pair of the nodes. Okay. You can have another configuration in which you have what we call an out star. That is the situation in which one node has two arrows going out to the two other nodes. Okay, and so forth. There are many different structures. And one of the very interesting things we found about a difference between the heroin and the cocaine flow networks is the cocaine flow network tended to have a larger percentage of what we call uh, straight line, directed line connections. In other words, you have three nodes in the network. A is sending to B and B is sending to C, but A is not sending to C. Okay, so in order for A to send to C within that set of three nodes, it has to go through B. That's a directed line. Okay, the interesting thing is in the heroin flow network, we saw a much larger percentage, not of directed lines, but of what we call out star to in star configurations. And what that is it's a directed line. So it's A sending to B sending to C, but also A sending to C. Okay, so A has two ways of getting to C in the heroin network, where in the cocaine network it only has one. Okay, it's a microstructural concept, but what it tells us is that in the case of the cocaine network, if you remove one of those arrows, you have potentially disabled the connection between A and C. But in the heroin network, if you remove any one of those arrows, either A to B or B to C or A to C, you still have a pathway going from A to C. Okay, so you have a network that's much more resilient in the case of the heroin flow network than you do in the cocaine flow. Okay? And this may have to do with the multiple sources. Remember, you have a golden triangle and a golden crescent, at least geographically, where in South America, it's essentially one geographic source for the cocaine, but that's speculation. Okay, and I'm going to skip over this because I'd like to leave time for Q&A. Let me talk about a couple of other applications and extensions. So we did a paper on MDMA, which is popularly known as ecstasy. I want to just show you a comparison between MDMA and cocaine, the maps, because these differences reflect the different sources of these drugs, right? So remember, well, let me start with the MDMA map. So this is a map from the National Drug Intelligence Center that shows us about flows of MDMA. Okay, so try to remember this. Basically, what seems to be happening is MDMA is coming into the United States from Canada. You see these thick purple interstate highways. Those are primary transportation routes. You see thick arrows coming down into the US from over the western border, the Vancouver-Washington border, and then through, of course, our local, our Michigan border as well, and then through the New York State, Quebec border as well, right? So there's a northern source. There's a little bit of evidence it's coming in from the south. There's something very funny going on here. The arrows going in all directions here, right? Let's see how it looks in comparison to the price map for ecstasy, for MDMA in the United States. This is the map of prices, okay? And what you see is this is actually a little bit less of a geographer's dream than the cocaine map was, right? Let me fast forward to the cocaine map. This is the cocaine map, beautiful four color, four quartiles, nicely arranged spatially across the map. You go back to ecstasy, it's a little bit more of a mess, okay? Remember those arrows that were going in all different directions? That's happening over here. This suggests that, and now let's think about MDMA, right? It's actually a synthetic drug. It's a lab manufactured drug. So it could very well be, because these are cheap cities. Remember, red are the cheapest cities, right? These are very cheap cities. Either something's going on here by way of production and then moving out to these more expensive cities. You can think of this as a price crater. Or we know that the Netherlands, at least in the decade for which we are looking at data, the early 2000s, the Netherlands were a major source of illegal MDMA, right? It could very well be, we are looking at the Atlantic seaboard, this is a landing point for internationally trafficked MDMA, okay? Notice some of the cheaper cities are up north. Vermont is much cheaper than the neighboring cities in Massachusetts and Connecticut and down in New York State. We got oranges here and then greens and blues. Michigan, we got oranges and reds along this interstate system that goes to Chicago. And if you look at our West Coast, we got oranges and reds. We've got oranges and reds going down almost the entire I-5 corridor, the Interstate 5 corridor, with a very cheap point in Seattle, Washington, which is close to the border. All right. So again, you do see some very interesting geographic phenomena. They look very different from what we see in the case of cocaine, and the contrast is actually quite fascinating to look. I wanted to bring one other phenomenon to your attention here because the next phenomenon I show you is going to be closely related to it. If you look at our cocaine map, oops, we've got a very clear price gradient here. Cheap, less cheap, even less cheap, most expensive, right? Over here, where are the expensive cities in our ecstasy and our MDMA map? There are a bunch of them here. And then there's this kind of line of expensive cities here. And then there are cheap cities to the west and cheap cities to the east. Okay. And if you think about how drugs flow, right, the direction of flow is typically indicated by movement from cheap to more expensive. If you were to convert this into what we might call a contour map with elevations, this would be a ridge. It would be like the top of the mountains cutting through the middle of the continent. Right? And what does that tell us? Well, what it tells us is we've got different entry points of MDMA into the United States. We've got a Seattle entry point, we've got a southern entry point in Southern California, and then we've got this Midwestern and this Northeastern entry point. It probably is the case that these areas belong to a different market or set of markets, perhaps even organizational structures, than do these areas. And there may even be another ridge going down the middle. If we had information for more cities, I'm sorry, there's a request here for annotating shared content. I'm not sure what to do with that. During annotation, you cannot control until you stop. I think I'm going to decline for now. I apologize to Sasha Dong, but it means I give up control of the screen for now. Apologies. Okay. So that's really how things are working over here. Keep in mind this ridge phenomenon as a possible delineation between two different markets and two different potentially trafficking organizations, or even more than two. All right, let's go back. And of course, I wanted to do a quick comparison with the cocaine flow network, and here it is, right? And the cocaine prices, which you've now seen. So now let's think about cannabis. These data are from, again, the early 2000s. The world has changed, at least the United States has changed dramatically since then in terms of legal regimes. But I still want to show you something quite telling. The NDIC, the National Drug Intelligence Center, for their cannabis data actually specified what type of cannabis they were dealing with. Okay, and they gave you price information for different types of cannabis. So one commonly accounted for type of cannabis is what they call Mexican cannabis. Okay, so these M's are basically Mexican cannabis. Remember, blue is the most expensive, green is less expensive, orange even less, and red is the cheapest cannabis, right? And what do you see here? Well, it's Mexican cannabis. You would expect it to be cheapest close to the Mexican border, and sure enough, it is. And then as you move north, it gets more and more expensive until you reach this blue ridge of prices, right? And this blue, and I guess you can include green also, because green is sort of kind of expensive, right? But this ridge happens up north, and then beyond that, you don't see Mexican cannabis. Something else is filling that market, right? So this is kind of a little bit more evidence that when you see these price ridges, you may be dealing with market boundaries. And you might have the question, well, what's on the other side of that market boundary? Well, I can tell you a little bit about it. There are more maps, but we don't have time. If you look at British Columbia cannabis, which was considered to be high THC, premium, high quality, whatever you want to call it, right? Cheapest just across the border from British Columbia. Remember, BC is over here, right? Cannabis probably coming down here. And here again, you have this ridge. This may be a sporadic, this is the LA market, who knows what's going on there. But you do see some evidence that we might be dealing with a ridge in the periphery of the Pacific Northwest. Okay, so you probably have BC cannabis running up against Mexican cannabis in cities along these ridges, and that has all kinds of implications for potential conflict, turf wars, the kinds of phenomena that we often see in relation to other drugs that are trafficked into and in the United States. Okay. And then finally, I just wanted to show you some of the most recent work we've been doing. We are in a collaboration with the Anti-Narcotic Police of Colombia. As you know, it's a huge producer of cocaine. We have some wholesale data, wholesale price data at the level of what they call the municipio, which is a very small administrative entity. You might want to think of it as something smaller than a county, but not really a township, maybe a little bit larger than a township. Okay. Here are price data for a small selection of municipio in Colombia. This is a major source country, again arranged by quartile. I'd like you to pay attention to where the highest prices are, indicated by black. You'll see that the prices are the highest in Colombia up here, down here. There's a region of somewhat high prices here, here, and here. And you might ask, what do these areas have in common? Well, a lot of them, in fact, all of them are potential exit points for cocaine out of the country. Okay. We know that there is a robust trafficking route into Venezuela. We know about shipping of cocaine across the Caribbean, up the Caribbean. In fact, we saw a presentation at the CINA GMU conference last spring that actually looked at some satellite data on this. And then these areas, of course, there's some trafficking going down south as well. And then these are sort of the larger city, the larger urban areas in Colombia. These are wholesale prices mostly. It could be that retail is influencing them, but these are also major airports out of Colombia. So it could very well be that the air traffic that's taking cocaine out of Colombia represents another area of the highest prices, right, before the drug leaves Colombia. And you tend to see the cheapest prices actually, by and large, in areas that have significant coca cultivation. Okay? But I don't have time to go into that in detail. For that, you want cocaine paste prices. We're currently working on a project that looks at paste, base, and hydrochloride prices and how the net chain develops as the cocaine moves along. Okay. Finally, we found one very striking finding. We are still looking for additional material to either validate or challenge this. But when we started doing the network analysis using price differentials for direction of flow and price correlations for linkage, we found that there were two very distinct clusters. They were two sub-networks and they had no nodes in common with each other. This was striking. Okay. So these are the two different sub-networks of cocaine hydrochloride in Colombia. The smaller is the circle, the lower is the price. The larger is the circle, the higher is the price. You can see they are by and large trying to do the same thing. They're sourcing from areas that are sometimes in the interior of the country. They're trying to get it out to areas that are on the border or on an internal border for airline trafficking, airline-based trafficking. And so this was a very interesting finding that we're still trying to think about in terms of, okay, what's the organizational structure of cocaine trafficking in Colombia? Does this have something to do with perhaps some kind of duopolistic, a duopoly of trafficking organizations in Colombia? Okay. So just by way of conclusion, we are coming close to one. I promised to end before then. Data on prices, seizures, and other economic variables are useful for understanding patterns of illegal commodity flows. We can actually validate a lot of what we see using what we know anecdotally and what we see on maps and in the news. One of the really compelling things about price data in particular is they are cheap and easy to collect. Okay, it's a matter of basically somebody asking somebody else, how much is this selling for? And that is information that is perhaps easier for people to divulge than where did you get it from or how did you get it and who's supplying it to you. And this is the reason why a lot of it is widely available as open source data. A very important point I want to reiterate is our list of inferred link is invariably different from the list of anecdotal links. So you always find linkages in the inferred list that are not in the anecdotal list. So there is always this element of value added. And sometimes, in some cases, it's actually quite striking, like this case of two possible mutually exclusive sub-networks in Colombia. Okay? So it has the potential to highlight links and phenomena that may have escaped the notice of drug policy makers and enforcement authorities who routinely report in an anecdotal manner what's going on. And then finally, as you can see, there are quite a few holes in the data, right? I mean, there are hundreds and hundreds of municipios in Colombia, but we had data for only a few dozen. And of course, it would be much nicer to have more comprehensive data. It would be very nice to have a continued series of data on the prices of the 6 major drugs that the NDIC was producing up until 2012 to make it available to the research community as perhaps a continued time series that people can sort of analyze and weigh into and supply insights into for the drug intelligence and enforcement and policy communities. And so I just wanted to end my presentation by making a pitch for, if there are people listening, higher frequency data collected at smaller jurisdictional levels have the potential for refining drug interdiction efforts and greatly enhancing our knowledge of the phenomenon, the really harmful phenomenon of drug in the United States and worldwide. So thank you very much. Here are a few references. The bulk of these are from our project because they actually contain the materials that were in the presentation. But I have cited the World Drug Report and John Calkin's earlier work that was very influential in starting us thinking about these phenomena. Thank you very much.